Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, it's that time of week again. It is time for another Let's Make It. This is episode 37, originally scheduled to be recorded on September 30th. And I will explain what I mean by originally. So if you were in the chat room on Monday night at 9 p.m., you realized probably we weren't here. And there's a couple, well, there's one main reason for that. But we're actually recording this a little later in the week because I didn't want to skip a week. But our content for that night was about a Rainbow Arduino, and Bob was going to do that. However, Bob had a family emergency on Monday, so he could not make it. So we just didn't do anything Monday night for Let's Make It. So we were probably gone. Like if you came here at 9 o'clock, you probably had been in reruns, and we had no way to really let everybody easily know that unless you're following us on Twitter. And if you're following us on Twitter, we did tweet that out that we would have no show that night. At that point, we hadn't determined what we were going to do. But this week I've been working on something. So I'm working on this switcher project for a video. And I'm actually now working on the audio control for the same switcher while I'm waiting to get the packaging and everything put together for the other switcher. The actual code and electronics part of it, the switcher is done. I'm still tweaking things here and there, but overall it's generally done. But there's also an audio component to at least the one switcher that I'm working with, and it has the ability to do audio control. But the only way you can control audio is via software on a computer. But what if you could do it physical control? So if you were going out for a job somewhere and you do a little bit of audio mixing and a little bit of video switching, why do you want to carry an extra soundboard if you can already do it with what you have? It's too difficult now. So I decided to work on an audio console. And it's not going to be very big. It won't be, it's only going to be a control surface, so it won't have all the features of a typical audio console. I'm going to rely on the switcher to do all this work. So what I've been doing is I wanted to make it so it was motorized fader, nice touch faders like that. But I'm getting in the motorized faders, and I think I showed you one a couple weeks ago. And I'm going to have one here. And what I've done now is I've written the code to control the motorized fader. So that's what we're going to get into this week. And I actually have two sketches I'm going to show you first. And a first sketch, and then I'm going to show you the test sketch that I've been running, and some little quirks here and there, and kind of how the design is going to work out, I think, in the end. So that's what I'm going to do this week. It's kind of a punt. This wasn't really planned, but since I had something I could show, I figured I'd go ahead and put a show together so we didn't have a blank week in there. So that's what this week's all about. So I'm flying solo again this week, and hopefully, if all goes well with Bob and his family, he'll be back on Monday. So let's go ahead. I'm going to hop over. I'm going to show you what I have sitting here next to me on the desk. So let's see. What you have here is an Arduino Mega. And the only reason I'm using the Mega is because I'm using the same motor control. Oops, didn't mean to move that. That I was using for the last week. And it covers up the buttons. So I wanted to have some control. Plus, I also need to bring input from this fader, which is basically just a linear fader. It is an audio tapered, so you'll see a little bit of difference when I show you this stuff. But the input from this into analog here, so I have analog 8, and then I'm using pins 36 and 38 for these two buttons for this sketch as well. The other thing you're going to notice is I have a battery here. That's because the motor that's in this motorized fader works in between 9 and 11 volts, or no, 8 and 11 volts. So I needed something to control it. The 5 volts of the Arduino would not move it. So this is an additional power supply just for the motor in the motorized fader. And I can try to turn it over here just to make sure. It's a little stiff because I'm using stiff wires for this. But there you can see the motor. And if you look down at the bottom, where my hand's not in the way, you can see I have two cables plugged in the bottom. Let's go this way. For the actual fader itself. So that's how I'm reading the fader itself. And the motor is just a plain old DC motor. And on the breadboard, the reason I have the breadboard is I need to bias what's coming out of this to ground, because if I let it float, it won't go completely to ground. And I need to know where this fader is. Now the fader moves freely right now, but there is a motor there. And I think I showed the other week how that actually works. There's like a little belt that goes around it, but the fader's moving free. Now what I've done is I programmed two positions, 75 and let me see. Before I lied to you, I programmed in 75 and 20. So if I hit the red button, it's going to go to 75%. That's 75%. Now remember, this is audio tapered, so it doesn't go, it's not linear tapered. And if I hit this button, it goes to 20, just like that. So I can go back and forth. And these right now are programmed values. I'm going to walk through the code to show you how this actually works. And then the second part of the show, I'm going to show you a little testing that I did, so you can see it's kind of fun. Never gets old either. But even after I move it, you know, it's easily movable by fingers, and at any time I can hit the button, go back straight to 75, go to, you know, whatever. So the ultimate goal of the project is to be able to read off the video switcher and move the faders to wherever it's set. And if somebody does go into control with software, the faders will move to where they are. The other reason I use faders is some of these switchers have quite a few audio channels on them. So if I decide to make an 8 slider or 8 fader board, and they have 16 audios, I can do layers, which is how a lot of, you know, digital soundboards work, is by layers. So it would allow me to put things back to where they actually belong. So very basic setup. You can see I'm actually running these to the breadboard for the motor, just because, I'm sorry, for the fader, because I need to bias it, and I couldn't easily bias it on the Arduino itself. So I run the fader controls directly to the breadboard. I probably could take in the 5 volts and stuck it in the pin there. I think it may have been too tight though. I can't remember what the reason was. I'd hit put on the breadboard. But then when the signal comes back, which is going to analog 8, it comes back and it's biased to ground with I can't remember what it was. I think it was a 1K or 10K or something like that. I can't remember what I figured out I needed to use, but it's in there. And then the 2 buttons are basically going to digital pins that are set for input pull up. So these just take out the ground. So every time I press, you know, one of these buttons right here, it goes to ground, and that's what the Arduino is looking for. And the 9-volt battery goes in. This actual motor shield actually has a connection for that, because I know a lot of motors are much more than 5 volts and would just crush an Arduino. So that's how you get the power into it. And I'm really only, I keep moving this, I'm really only using one of these chips, and half of it at that. So in the final design that I'm going to do with the soundboard, I'm probably going to, since one chip can control 2 different faders, I'm probably going to put 2, you know, do it in groups of 2, and use the H bridge that's right there for 2 faders, and so I can just save the amount of chips I need to use. So if something ever go bad, they come out in groups of 2, which is not bad. So I think that's acceptable for what I'm trying to do, and it just makes the design a little bit easier in the long run, because you use a one chip to control 2 different faders. And similar with the LED meters, I'm going to use a shift register, and I'm going to split them in half. So it's a 16-bit shift register, and it's so I'm going to take 8 bits for each meter, and that'll be the meter for it. So I can take one shift register and control 2 channels. So basically doubling everything up in that process. So what I want to do now is I want to hop over to the code, and I'm going to walk through the code that I have. This is actually very simple, and it's going to show you how I did the button just to show you. But then when I came back from break, we're going to go ahead and we're going to show you an automated thing that I was testing just to, and I'll tell you what it is. I had some problems figuring out how to get this to work. I was trying to slow it down before it got to where it went, which confused it. So I ended up just keeping it at full speed, which you'll see in here. I do have some of the older code. I think it's in the second program where you can see where I was trying to slow down the motor, but really slowing down the motor made it take a lot longer to get to where it wanted to get. So it was in keeping it full speed takes it like directly where it wants to go. So it worked really well. So let's hop over to the code real quick, and you're going to see at the very top here, we include the AF motor. Accel stepper probably isn't required for this because I'm not using a stepper motor, and I'm not using that class anywhere in here, but you can see this from last week. I just copied this top part. I defined the 2 pins 36 and 38, as I mentioned. I called them forward and backward because when I first originally wrote this, I was using the buttons to move the motor each direction, and now it would just be button 1, button 2. Then we have our sensor pin. I said it becomes an analog 8. So this is the other half of, so basically we're sending 5 volts into the fader, and then we're taking the result of that back into A8, and that's why we have to bias it to ground, because if you don't do that, it's going to float and can never get back down to its bottom value. We're setting our motor speed at the top, 250, and like I said, I'm using when using a motor with this shield, we can actually control 4 motors. I'm in position number 3, so I'm only using 1/4 of this board. And we come down here and we do our basic setups. So we're setting our buttons for input pull up. So they're going to be biased towards positive. We take them to ground. We're going to send them like when they're pushed, they go to ground. I'm setting the speed to 250. right here for the motor speed. And I'm telling the motor not to run because I don't really want it to do anything when it first comes up. And then for logging purposes, I begin the serial port, and you'll see down through here I'm doing some commenting through the serial port. So here's the loop, and if digital read forward, if it's not digital read forward, it means the button's pushed to ground. So I'm going to print to the serial port F just so I know that the button F or B was the time was forward or backward was pressed, and then I'm going to set the fader position to 75%. So you'll see why I say 75% here shortly, because it really is 75%, but it's based on if it's your linear audio tapered, and I'll discuss that in a little bit here as well. So here I'm checking for the other button, which was one time called backward. I'm putting B, and I'm saying to go to 20%. And if neither one of these are pressed, I'm saying don't run the motor at all to make sure the motor is not running. So here's the routine that actually sets the fader position. It's actually very simple. So we come in, we pass in the position, we set the current position, and then we read it. So you see this map command. We talked about this map command once before. So what I'm doing is when you analog read a sensor, it comes in between 0 and 1024. Now, in the case of the resistor value that I use, the lowest it would ever get is 480, and the top of 1024. That's a true 5 volts. So I'm mapping the 480 to 1024 to 0 to 100. So that's where the percentage comes in. So if I say I want 90%, it's going to go of 90% of whatever the 90%, 1024 minus 480, 90% of that value added to 480, that's where it's going to take you. So this map command makes all this that simple by doing that one map command. So now that I know where my current position is, I come down here, and while I'm taking the position that I want minus the current position, and if it's not there, then basically greater than 1, so I'm not at 0, because if it's where it needs to be, position and current position are going to be equal to the exact same thing. So I'm basically saying if it's not equal, so I could have done, and the reason I did this greater than 1 is I was playing with different values. I could say here not equal, but I was playing if it's greater than 2. So if it gets within 2% of where it wants to be, stop. That's kind of how I was playing with. But I figured out that after messing with it, I could get it down to 1. So I can now say not equal to 0, and this would be the same thing as saying greater than 1 at this point. So now I need to determine which direction do I need to go. So if the current position is greater than where I want to go, I need to go basically down the negative. Now it's going to seem funny saying forward and backward. It's just the way this motor runs, and the way I have it wired, forward and backward are the opposite of what you would think. So don't let that confuse you. So if where I want to go is greater than, where it is greater than where I want to go. So I'm going to come down here and I'm going to say if it's, you see the same thing right here where I'm doing greater than 1. That's because I had some slop. I had that greater than 2 in here at one point, greater than 7. I was trying different things. So here I could also say the same thing. I kind of almost, with the way I'm doing this now, is get rid of this whole if statement. But I wanted to leave this in here because I think I may want to do a little bit of play so it's not exact. And I can kind of explain, it got a little bit of vibration at one point. However, I think I've gotten it out now. So it's something I'll go back and I'll revisit. But basically what I'm saying, the same thing here, is if it needs to move, then turn the motor on forward. And then if it's the opposite, say it's not current position, it's greater than position, so I need to go the other direction, it comes down here and I'm checking it out right here. So I'm basically doing the opposite effect right here. I'm going backwards. And then I reread this current position and I continue while this loop doesn't fall out. And then when it falls out of the loop, I say don't run the motor anymore. So basically I'm sitting in this loop watching for this value to equal, and then when it does, I fall out of the loop. And that's it. So we're actually going to try something here. We're going to run the same thing. I'm going to try this right live. I love to run things live because they blow up. It's fun. Let me go ahead and I'm actually going to get rid of these if statements and see if my thinking is correct, which would make this much simpler to demonstrate, actually. This would go back one more, just like that, and let's get rid of these extra lines. And actually I can get rid of this too, just to make it even cleaner. Let's move this back. So you're going to watch a success or a failure live right here. All right, so there's direction. That makes it a little bit easier to understand, doesn't it? If this works. So let's go ahead and upload this. Just like that. And then we're going to come back over to here. And see. Wow, ain't that neat? I'll make sure I put the new code, this new code, up there so you can see how simple that little routine is to set fader position. All right, so as I mentioned before, we're going to hop in and let's see. Gonna take a quick break, a little disheveled tonight, sorry, and we'll be back right after this.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
All right, I'd like to thank all of our sponsors for this show. They definitely help make this show very possible. Any little bit we get to help fund some of this stuff, fund our servers and stuff like that, it is a help. So definitely appreciate all the sponsors. All right, so before we went to break, we showed you the button thing I was doing. So what I'm going to do is I'm going to actually change programs and go to the other one, which was, let's see. And the thing with this is that you're going to see the actual same code I had before. So let's see, here we go. So here's the code. You're going to see very similar. You're going to see I still have the buttons in here because I did this after I did the other routine. But we're going down here and you're going to see something a little bit different. So I didn't change set fader position in this one yet, but what I did is I printed out to the screen where I was going like this, and you can see that I'm just doing different positions, waiting 2 seconds, and then going around the loop. You see all the old code still in here, because if I push the buttons, it would do something. But so what I want to do is this is going to go to 0 to 33 to 75 to 100 to 25 to 60, and then do it all over again. It's going to wait 2 seconds between each one. So it's like a little test that I was doing because I was getting this vibration at one point, and I didn't know what was causing it. Ended up being that I was actually shooting past where it wanted to be, And then when I went back, it was not there anymore, and it had shot past it. So I was using this to test that, because sometimes it would get somewhere and it'd shake a little bit and then stop and go somewhere else and then go somewhere else. And then every once in a while it would just stop and shake. And I was trying to figure out what it was. So this is the test program. But it's a good example of how fast these little faders are. So what I'm going to do is I'm going to switch over to the code, and you're going to see me upload this. And then I'm going to bring up the serial port. So I'm going to go here to Tools and go to Serial Monitor, and what you're going to see is the different positions that it's sending to. And then what I want to do is I want to go over to the device itself, and you're going to see it move to those different positions. And it's amazing how fast it really is. I mean, I was a little concerned, and I was really concerned when I was trying to slow it down, because I was thinking with the vibration I was overshooting it, which I was overshooting it, but I wasn't overshooting it for the same reason I thought. So what I was doing is if it got within like 10% of where it needed to be, I would turn the motor down to 200 and let it slow down. The thing is, it is really slow at 200, so I went to 225. Eventually it got to the point where it didn't make any sense not to just keep it at full speed. And when I figured out that I was actually not turning the motor off fast enough and was overshooting it, then I figured I just took out all that extra code that was in there. In fact, I can show you how I was doing it in the code I'm running right now. Let me go get that back up. And it's still going to look a lot like the old one where it had the different directions and everything, but you'll be able to see in here how I was doing it. Let me get it up here. All right, let's go back over to that. All right, so what I was doing is, this is the same routine. You see the still debugging code in here. I was determining if it was at the right location and then the direction. And then what I was doing is if it was less than 10%, I would set the motor speed down to 200. But if it was greater than 10%, I'd set it to 250 at full speed. The problem was when I was doing it this way, and when it got to where it was supposed to be going, it literally went to a crawl and took 5-6 seconds to finish off that last little piece. It wasn't going nowhere near as fast as what this thing is right here. This is going super fast compared to what it was doing. And actually, and it's very neat. I was very impressed. Now, I've gotten some small ones. This is a 100mm fader, and I've now gotten the 60mm, because I'm not quite sure of the size of the case or the enclosure I'm going to put this in. I'm actually going to meet this Tuesday with one of the manufacturers of the enclosures and see what they think the best way is, because I'm not a mechanical engineer, so this is a little bit out of my element as far as doing work. I mean, I can write the code and I can write the electronics to work, but I'm not the mechanical person who can put it all into a case and make it look nice. So that's where I'm going to go talk to some other people. But anyways, this week was supposed to be the Rainbow Arduino, but like I said, we had, with Bob's family emergency, we just couldn't do it. And I didn't want the week to go without Let's Make It. So I decided to put something together, and this is something I was already working on. So I thought, well, I'll just show a thing. It's quick, but at least you're not going to miss us for this week. All right, a few little housekeeping things. You can watch all of the Let's Make It shows if you want to watch on YouTube. It's youtube.com/techzentv. You can send your friends there and they go and watch this show and all the other shows as well. All of our shows are segmented out into playlists so that you can only watch the ones you're really interested in. You don't have to watch them all if you don't want, but I think you'll find some of the other ones are pretty nice anyways. So if you're going to tweet about us, you can tweet us at our direct messages either way at TechZenTV. And if you're talking about this show, make sure you use the hashtag #Let's Make It. And if you're on Facebook, which just about everybody is, I'm on Facebook, but I don't really use Facebook a lot. But we do have a Facebook fan page. It's facebook.com/TechZenTV. Go out there and hit the like button. That would be awesome if you did that. And you can go to TechZenTV for all of our show notes. And if you want a little trick, if you go to Let's Make It.tv, we take you right to where you need to be in the site to get to all the information about our past episodes and show notes and stuff like that. You skip right through the whole site and go right to the Let's Make It page. It's just a little bit of a shortcut. Now, as I mentioned before, we do normally we record this at 9 p.m. Eastern. And if you are watching this because you couldn't come on Monday night, I'm sorry. We just had didn't have much of a choice. And if you follow us on Twitter, you would see that we did tweet out that we weren't going to have a show tonight. And we didn't really have any plans for to make up the show, but I just didn't want to have a week that we didn't have anything. So I decided to make it up, even if it's a little bit shorter than normal and maybe a little bit less detailed. And, it's some things we talked about in the past. So we talked about potentiometers in the past. We talked about motor control last week. So I just kind of combined them together and showed you how a motorized fader works. So anyways, Monday nights at 9 p.m. Got TechZen TV/live. We're also on Alexa TV now as well. And as Alexa TV is on Roku, TechZen TV is on Roku. If you're downloading us, a podcast, which is the best way because you just get it automatically. You don't have to worry about when the show's on and go looking for it. It'll just download right to your device or your computer and you can watch it right there. I would definitely appreciate if you go out and you give us a 5-star rating out there wherever you're getting your podcast from, because all that really helps us to get found. It's very important to us to get the show out there as much as we can, and we love to spread the word, and we appreciate everybody spreading the word. I've gotten some emails this week. I didn't want to really talk about them yet without having Bob on, because he hopefully he's come back on Monday and we talk about some of the things. But I've got some interesting ones about scales and a few other things too. And we will maybe talk about that on Monday. So we will have a show on Monday night, even if Bob can't make it. I'm a little more prepared now for something if something happens that Bob can't make it. But we wish him and his family well, and hopefully everything works out good for them. All right, that's it for the Let's Make It this week. We'll see y'all next week. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.